Okay, we go for the next part, which is the water distribution system. Right. Okay, so why do we need to have a water distribution system? Basically, is to satisfy the water requirements. Okay, we distribute the water to the domestic, commercial, industrial, and firefighting purposes. So, what kind of system that we like to have? Okay, we want the system whereby it can give sufficient capacity of water, sufficient pressure, and it's good to have a low cost system, because if you have a low cost system of distributing water, then the cost of water will be very cheap, and it has to be easy to maintain, and they must have a stable condition. Okay, that's a good criteria for a distribution system. Right. So, what are the water distribution system? Okay. So, they have three kinds of water distribution system. The first one is gravity system. What do we mean by gravity? Okay, look at our diagram. Okay, this is how a gravity system look like. I think you have already drawn this diagram, right?
Yes.
Okay, that's great. Okay, so you have your supply source at the high level compared to the service area. Okay, imagining your river, the supply water is on top of the head. So it goes down naturally without any pump. It goes to the treatment plant. Okay, so they are doing treatment over here from aeration, flocculation. I'm sorry, aeration, coagulation, flocculation, sedimentation, filtration, and disinfection here. Okay, still on top of the hill, high level, and then it goes naturally down without any help from the pump to go to the service reservoir. Okay, so from this service reservoir, it will distribute the water to the service area, to new township. Also goes down naturally without the help of any pump. Okay, because of the source, the treatment, the reservoir is all at a higher level compared to the service area. Okay, I have an example of it. So before I show my example, I think I would like to um, pause my recording. Okay, this is a very
It's
old
so much.
water treatment plant. Can you see my picture over here?
Oh, mantul, mantul.
Oh, that's great. Okay,
Nice.
I got the permission from Syarikat Air Johor, okay, to visit an old water treatment plant. We call it as Gunung Pulai water treatment plant. So if you can see, very old system, water treatment plant system, the source, water source is on top of this. Okay, it's basically here. So it has to go down, okay, and then the treatment plant is there, and then from that treatment plant, it will be distributed to the area in Johor Bahru. Okay, some part of Johor Bahru. So is there any other pictures? Okay, this looks at the water source, how it's a very clean water. It's not like yellowish color, okay, like teh tarik, okay, but it's a clean water. This is the water treatment plant over here, and it has got to go to the top of the hill for the water source. So they don't have pumps. The water just flowing in the gravity. Because of the gravity, it flows down to the water treatment plant over here, and even the bus cannot enter here. This is on top of a hill. Okay, so bus park here, and then all of us get off from the bus to visit the water treatment plant at this place, and then even further up is the water sources. Okay, so this is the chemical rooms where they store the chlorine and also alum. Okay, very old system, and this water is actually they distribute the water to the Johor Bahru area, some part of the Johor Bahru area. Okay, so I think that's probably that I want to share. Okay, I hope that you got some ideas on uh, the water treatment plant. Okay, so that is the gravity system. So what are good things about gravity system? Distribution is carried out by using gravity forces. They don't use pump at all. and it's also suitable for water level, or the water level is higher than the service area. They're not using pump, and it's definitely low cost and very effective. So in reality, it's not very easy to get a gravity system. Sometimes we may have a direct pump system. Okay, so what do I mean by direct pump system? The supply source, okay, the water supply or the river that for our water source is actually below the level of the service area, or even at the same level of the service area. So it may need pump to be pumped to the treatment plant, and it also needs another pump to be pumped to the service area. Okay, so the pump will have to pump continuously, and it's an expensive system, and the pump may break down sometimes, so you need to repair the pump. Okay, so cost of maintenance also high. The electricity cost to run the pump also, we do have the electricity cost and maintenance cost, so it's an expensive method. Okay, so another thing that I'd like to mention, I think, is on the usage of the pump is vary. What do I mean by that? Okay, imagining at 12 o'clock at night. Okay, not very many people are using water. Okay, perhaps people are sleeping. So let's say the water is pumping at the rate of 100 liter per second to this area. In the morning, okay, at 7 o'clock in the morning, people have already woken up and they start to take shower. The students, their kids are going to school, so everyone take shower, having breakfast, and so many things happening. Okay, at that time during at 7 o'clock in the morning. So let's say the water, the need of water is very high at the service area. Okay, so instead of 100 liter per second, so it probably 500 liter per second at 7 o'clock in the morning. That means the pump has got to pump really, really quickly to be able to satisfy the demand of the water at this area at 7 o'clock in the morning. And now at 10 o'clock in the morning, so everybody has already gone to school, people have already gone to work, to the office, so not very many people are living in this area. Okay, perhaps the helper are staying in the house, so they don't really use much water. So now the water needed in this area is very, very little. Let's say it's about 200 liter per second. So now the pump is pumping at a different rate, okay, at 200 liter per second. So imagining within that 12 hours, so many pumping rate, okay, we start with 100 liter per second, and then suddenly it changed to 500 liter per second, and suddenly it changed again to 200 liter per second. So this pump keep changing their rate of pumping. Okay, that's not something that we would like to see. If the pump keep changing their rate of pumping, that means the possibility for it to break down, okay, because it keep changing pumping, so it's very huge. Okay, so maintenance works is needed for the pump. So that is the problem with the direct pump system. So I hope that whatever things that I've said is already explained in this in your notes, okay, or in this slide. Then we move on to the last part of the distribution system. Okay, can I move to the last part? Sorry, I forgot to ask that.
Boleh.
Okay, thank you. Okay,
Boleh, doktor.
we go to the gravity and pump combination. But for the gravity and pump system, now they are combining a different type of system. Okay, although the water supply is below the level of the service area, or even at the same level of the service area, so they have pumping rate to the treatment plant. So this is where we treat water. Then after disinfection, it will be distributed. So now they have one pump and one service reservoir. So how do we deal with this service reservoir? Okay, remember, this is the service area. If you remember that I told you just now, at 12 o'clock at night, okay, so only 100 liters of water is needed at the service area. But this time around, the pump is pumping at a constant rate. So what do we mean by that constant rate? Okay, so okay, let me do some calculation over my head. Okay, in my head. Right, it will pump at 400 liter per second. No, at 500 liter per second. Okay, the pump will pump at 500 liter per second. So at 12 o'clock at night, since the service area needs only 100 liter per second, that means the water from this pump will go 100 liter to this area, and another 400 liter will be saved at the service reservoir. Okay, at the service reservoir.
Okay dah.
Alright. Let's say during peak hours, the service area needed 900 liter per second. Let's say it needs 900 liter per second. So the pump will always pump at 500 liter per second. Now it will directly provide 500 liters per second to the service area. Okay, it's not enough because I said that during the peak hours we need 900 liters per second. So 500 directly goes there. Remember, we have 400 being kept at the service reservoir. So this 400 will help to provide the water needed. So 400 plus 500 being pumped will be 900 liter per second being provided at the service area during the peak hours. Okay, so whenever, or in other words, this pump will be pumping at the constant rate. So if the service area need little water, so that little water will be sent to the service area, and the others will be kept in the service reservoir. So if the service area need more water compared to the pumping rate, so the service reservoir will help, okay, to supply the water needed at the service area. Is that clear? That's
Clear.
great.
Yeah,
Okay.
clear. Thanks. Yeah.
Okay, thank you very much. So since the pump, it has been using a constant rate, okay, but the pumping rate is constant, so the possibility for it to break down easily is very little. Okay, not like in the previous example where the pump keep changing their pumping rate, but this time it will be constant throughout the system. So this one is better, a gravity and pump combination system. So not very many people, or not very many area are lucky to have a gravity system whereby they don't need pump. The water flows naturally due to gravity. So most probably, most of us are having direct pump system, but in order for us to improve the direct pump system is by combining the gravity system by providing a storage reservoir in our water distribution system, and that's why it is being called the gravity and the pumps combination. Okay, the gravity part is being provided by the storage reservoir, and the pump system is being provided by the pump.